the concept of smart city. So here, the concept is to understand what is a smart city. So the concept is about making a city, turning a city, normal functions of a city, into being a smart. So basically, a smart city is an urban area which uses different types of electronic methods and sensors to collect data in real time. It could be any kind of things, including traffic, air, water quality, and solar radiation. All these insights gained throughout all this interconnectedness of data helps mainly government organization and public departments to manage assets, resources, and services efficiently. In return, that data is used to improve also the operations across the whole city. So basically, intercity, this concept of intercity works as an IoT, really smart lighting system in this case, which was developed by Signify, that improves the city services and safety. It's an innovative tool with a lot of potential to integrate different type of city services to make a city become smart. And the different types of use cases, as we can see here on the slide, are different. We have 5 different use cases which can be operated under the concept of intercity by Signify. We have the energy optimization concept, which is all about reduction of CO2, how we use this concept of the smart city, all this data to make sure that the concept of CO2 reductions in the city is reduced. Environmental monitoring, which also follows a little bit the concept of energy optimization. Scene management, where, for example, each pillar or light bulb can become itself a camera, which can monitor what's happening in different streets. And also in the same concept, the use case of incident detection. So we have traffic and roads and cars, and the idea of having cameras installed all around the city, transmitting data instantaneously and potentially to identify incidents which happen, could be cars or even people incidents. And then the last use case is the remote management and monitoring of the citywide infrastructure, which is the use case which we have identified for our use case and which we'll be describing later on now.
So our use case, as Ivan said before, is the remote management and monitoring of citywide lighting infrastructure that is realized by a lighting asset management and by a dashboard software. The lighting asset management software provides the possibility to have a full visibility into the lighting infrastructure and manage the lighting related workflows from an app and view data from a centralized dashboard, identifying fault alerts for a quick response. And now Valentin is going to explain the benefits for city managers.
So yeah, mainly we have highlighted 5 benefits. The first one is the visualization, which is key because it gives the city manager quick access to the information. Then the automatic fault detection can be, it's made via an algorithm that will be able to detect when something is going wrong in the lighting somewhere. It can be added with some, for example, meteorological data and other sensors to do predictive maintenance in the system. The central intuitive asset management that is easy to use, and for example, the city manager can also program their own applications with the data. Improve public service. So if your light work better, then you improve, for example, the safety or the feeling of safety of the people in the city. And it helps for the decision making with the quick access to the data.
Here are 2 patents, this slide and next, related to this use case, the use case of remote management and monitoring of citywide lighting and infrastructure. Brief description about this patent is that this is a combination of some tools and systems such as outdoor light units having acoustic or light sensors or both, also a central management system and a resource server. Also here's a network system which lets the communication between tools and these tools and systems resulting in determination of event occurrences around or near the outdoor light units. Also enables a dissemination of information about a unit light's status and initiation of appropriate commands and actions to light units. So this network and management system allows creation of those benefits my colleagues mentioned in the previous slide, and in details easier management of light units and required workflows, real-time monitoring to find anomalies, and rapid responses and actions to minimize the downtime. With this innovation, which started from defining the required solution to adapting the service specification to that solution, we can see how customers can benefit from an integrated and streamlined lighting infrastructure. And Audrey will explain the second patent.
Thanks, Anaïta. For the use case remote management and monitoring of citywide lighting infrastructure, we identify this second patent on a sensor network with adaptive detection settings based on the information status from the luminaries and connected devices. So it protects an infrastructure with sensor detecting environmental conditions. And this server is sending information from the sensor to the central management system. Information like traffic light status and security data or pedestrian data are sending. And then the central management system receives status information, estimating, for example, level of traffic, and adjust the lighting strategy and function. So this allows for this use case improvement of sensors detection accuracy. Detection robustness of sensor is increased by minimizing missed detection. And it also allows for rapid response on minimal downtime by identifying lighting failures through real-time fault notifications. So by developing this concept of smart and efficient lighting system, we have value creation, like for example, with the example of Philips StarSense telemanagement solution to connect, control and diagnose lighting installation with down to the individual light points, and also the sensor of Philips Lumination that includes data and processing unit to detect the presence of a person close to a light source and turn on the luminaire. So Signify here combines the sensing and communication capabilities to make a lighting system a smart sensor network that can be exploited to improve the overall system performance. And I let Alex present you the possible use case for Interact City.
Thank you. So our next task was to think of further use cases that could be applied to that could be used in the ecosystem of Interact City. And we thought that why not only cover the incident detection by cameras or microphones? Why not expand this to use the lights actually as an information tool to inform road traffic participants about emergency? And that's how we came up with the emergency light scenario. Those are city lighting units that react dynamically to local emergency situation, as you can see, for example, in that nice right little illustration. If an emergency is detected, then this could be done automatically by sensors in smart lighting systems, or also manually activated by emergency operation control and communication center, or manually by approaching first responders and fire trucks. And that could, for example, look in the following way. Upon this manual or automatic accident detection, we have an automatic increase of light brightness directly at the accident spot. And also the light color changes, for example, to red here directly where the accident happened. In the right illustration to indicate where it happened, and also maybe around the spot to have some area where the lights are blinking to inform other traffic participants of that something has happened there, to warn the other road users. And then we can also use microphones, for example, to detect those accidents, also together with cameras, of course, so that those emergency lighting scenarios automatically start. And to take this even further, which is so as far to our knowledge not yet really covered by Interact Cities, that we can also expand this to traffic lights, so that the traffic lights, for example, automatically turn red when there is a first responder or police crossing, so that they have automatically the right of way. So what would be necessary to protect such a use case? What framework and what protection rights? So we would, of course, on the product side, we would need dimmable smart light units where the colors can be changed. We can protect those by patents. Also, we would need an interface to the traffic or emergency operation control unit. We can have a patent also for this interface. And as far as security is involved, we would also, of course, need some kind of encryption, so it cannot be hacked. And of course, such algorithms would need to be kept secret. Then we would also need methods for automated incident detection. For example, sound recognition when we use the microphones, or visual pattern recognitions, that, for example, the cameras automatically see accumulations of traffic, like traffic jams and things like that, so they can automatically go into the emergency light scenario. And we could also cover this with and protect this with patents or secrecy. Also, one thing that takes it a little further would be a communication protocol between the vehicles and the smart lights. That could be, for example, via Li-Fi, so that the light flickers in a certain frequency range and thereby transmits automatically information and data. And that, of course, can also be protected by patents. And now please dedicate all your full attention to the following nice presentation of Jan for our second use case.
Thank you. The second use case approaches a problem that is not so apparent and for us humans, but it's actually a big problem for insects. That's light pollution. It turns out that light pollution is one of the biggest cause for the reduction of biomass and insect biomass next to agriculture. And on the other hand, insects are also a problem in some parts of the world when it comes to certain diseases like malaria and dengue fever. So there seems to be a problem with the control of insects in the vicinity of cities. And when we think of the LED lights that we want to now distribute within our city, it turns out that LED lights attract even more insects, and they could even harm the ecosystems even stronger. And so our idea to deal with that is a use case named active insect management. To identify the problem first, let's take a look on this little guy. It's a moth. Let's call him Bugsy, the friendly moth. And it turns out, unfortunately for him, he's attracted by light. That's no problem for him during the day, but during the night, it can be deadly for him. And if we take a look and what really attracts him to this, and take a look at the spectra of this LED light, it turns out there is what we can call a moth window. Bugsy is particularly attracted by ultraviolet and blue light. So the idea can be that we actually actively tune the emission spectra of our light, so that we have like a switch on each light bulb where we can switch the attraction for Bugsy. So we reduce the emission in the ultraviolet light, and we reduce the attraction for Bugsy. So the idea is to have this benefit, the reduction of the insect attraction and the active tuning of this insect attraction. If we look on what's the technology that we are contributing here, which it's an improved light bulb that has a reduced attraction for insects, and this is a classical application for a hardware patent to protect this. When it goes one step further to our problem, it would be good to know where are the insects within our city. So the idea is to use cameras that image the real vicinity, the vicinity of our city lights, and image Bugsy and his friends. So we identify where is Bugsy, where are his friends, we count them, we identify them, and we record them and show them, can draw something like this, where we have a city light with a city map with the highlighting where are our insects, and this is live data that we collect during the night. So we record and have like can identify hotspots. The technology we use for that is the sensors, it's the camera. We have the benefit we can record the data, and this data can be protected or is protected by database rights and data protection rights. And finally, how can we help Bugsy? Here it's still bright in the city, much brighter than in the nature where he wants to live. And unfortunately now he's trapped in the city. And how can we help him out? Well, he's still attracted to the city, but now we use a data-driven approach to that and use a data-driven lighting orchestration. The data sources we are using, of course, we use our live insect data that we have collected. We use vegetation data, like from tree catasters. We use city data, of course, where are the city, where's the vicinity of our city, and of course we use weather data that we don't guide Bugsy against the wind, for example. So, and with this lighting orchestration, we can now guide Bugsy outside of the city. We just need to switch on the next light. Here we switch on the moth window, so Bugsy is more attracted to this lamp than to the other, and there is a fair chance that he makes it to the next city light. Of course, we are not interested in Bugsy himself, but we would be happy if some of his friends and family make it to the next city light. And if we continue with this switching scheme, we can actively pump out the insects out of the city. So instead of only reducing the attraction, we for the first time send an active guiding force against the attraction. So we're actually actively driving the insects out of our cities. So the benefit or the technologies that we're using is data and AI. The benefit we generate, we have like an active control of the insect population within our city. And this we can protect by the use case patent and of course copyrights. And finally, we can think of, well, what else can we do with this technology? And we think we can make here, create a real differentiation for the consumer market. Today, people actually buy some items to help insects and the insect population. You can see here a luxury insect hotel that you can buy on Amazon for 65 euros. And maybe people who are buying that maybe also buy like a special light bulb that has the same ability, a reduced attraction to insects, but that can also be integrated within this city lighting orchestration system, so that the consumer can become part of this network. And of course, there is another big industry that is dealing with active insect management, and this is agriculture. So we can create new business on basis of our domain knowledge that we have collected from the city lighting orchestration. The benefit that we have is the new business, and for example, we can use trademarks to transport this differentiation from our use case in the city to the consumer market. And finally, we have like a full-staged orchestration, not of our city lighting, but also of our IP tools to support each contribution that we are giving to this whole story, so that we can say in the end that we are part of the solution and not part of the pollution. Thank you.